So we're going to start with the first unit of computer organization and architecture, which is instruction representation. To give you a broad overview of what we will be learning in this chapter, when you write a program asking a computer to say add two numbers, generally what we would do is you initialize two variables, let's say x and y. You say x equals 5, y equals 10 something, and then you say z equals x plus y, print z. That's a general course of action if your objective is to add two numbers. And what the computer does, what we've studied so far, is it takes two locations in its memory. It allocates one as x, the other as y. It puts the values 5 and 10 respectively in those values, in those locations. Then when it encounters the statement z equals x plus y, it creates another location in the memory called z. Then you have this part of the CPU called the arithmetic logic unit, which performs the arithmetic operation of addition. It takes 10, it takes 5, it adds them, it returns the value 15. That 15 is put in the place labeled z. And then when you come across the statement print z, that 15 is taken from that location and displayed on the system. So a high level overview of how any program works is this. But when you zoom into the CPU, apart from the arithmetic logic unit, you have something called the control unit. You have something called registers. Registers are a very important part of the CPU, and any operation you perform on any data in your computer cannot be performed without a register. So it is actually not from your memory but from the registers that this data is taken and acted upon. It is not into your memory but into these registers that the data is put back. So you might not have a clear picture of what exactly this register is and where it comes into place right now, which is okay, we'll go into that soon. But the idea I'm trying to convey is that the register is a very important component of the CPU, without which it would be very difficult to carry out all the computational tasks which your CPU does. So what is the role of the register? Where is it located? How does it work? And how are instructions conveyed to the register? Is the register capable of directly understanding the code we write, or do the instructions have to be translated into some other language which the register understands? Those are some of the ideas we will be addressing in this unit. So before going into the registers part of it, we'll start with a quick overview of computer organization. So a computer, as you all know, is an electronic machine which takes input, processes it and gives back the output. So it's an input processing output machine. So organization and architecture both refer to hardware related concepts when you come to a computer context, but there is a slight difference. So organization refers mostly to hardware, to the structure itself, whereas architecture is also about the function plus the structure. So for example, if you remember from your digital design course, you had this concept called structure of an SRAM cell or structure of a DRAM cell. So you have a cell, then you have some encoder, decoder, some combinational circuit there, you have some selection lines. If this line is a 0, the read operation is carried out. If this line is a 1, the write operation is carried out. You had some logical setup there. So if I just draw the circuit, the connections, and explain this is an encoder, this is a static RAM cell, this is a transistor, that is the organization part, where I'm just talking about what components are there, how they are connected to each other. If I go one step further and talk about how that helps me implement an SRAM cell, like if I say when this line is at 0, this is activated, so the read activity happens, this data is taken here and put here. If this line is switched on, when it becomes a 1, this becomes a 0, its complement is activated, so the data is picked up, a write operation happens, something. So if I'm going to talk about how the hardware helps in implementing a certain function, then we are dealing with the architecture. So both Organization and architecture are related to hardware, but organization is just a structural context. Architecture also deals with the functional behavior. That's the difference between organization and architecture. And in this course, we will be looking at both, which is why it is titled COA. We will be looking at the hardware setup, some parts of the hardware setup, mostly those related to memory, and why they exist, what function they perform, what they're trying to do. So that is a broad overview of the course and the first unit.